Alright, what's up guys? In this video we're going to pick up with some calculus here. This is going to be another integration practice video. This is going to be example number 53 of the integration practice series. Alright, so we need to evaluate the integral dx over the square root of 9 plus x squared. So this is clearly a trig substitution. And if you notice the form that we have here, again, trig substitutions don't have to be under square roots, but this one is. And what we got here is the square root of a squared plus x squared is what we have. So anytime we see that, we know that this is going to be a tangent substitution. So x is going to be equal to a tangent theta. So we need to know what a is. Well, if a squared is 9, then that must mean that a is 3. So therefore, x here is going to be 3 tangent theta. Now we need to differentiate that. That'll give us 3 secant squared theta multiplied by d theta, because the derivative of tangent theta is secant squared theta. And in my videos, I don't skip steps. I always include all the steps, including the simplification process. Now you can avoid most of this if you're actually doing it in a class. You can kind of or during a quiz or test, you can do the simplification in your head and not write down all the steps. But in my videos, I write down all the steps, which I think makes my videos a little bit different, because most professors will kind of do the simplification in their head as well, and expect that you know how they got from point A to point B. And they'll kind of leave it to you on that, but I don't do that in my videos. Because I don't know who's watching. Anybody could be watching and may not know how to get from point A to point B. So if I'm not telling you what I'm doing, then I'm not really helping you at all. So we're going to clean the square root up a little bit. We'll do that first. So let's take care of that. So that's just 9 plus 3 tangent theta squared. So let's deal with that. So that's going to be 9 plus 9 tangent squared theta, because we're squaring not only the 3 but also the tangent. And if we simplify this, this will be 3 times the square root of 1 plus tangent squared theta. 1 plus tangent squared theta, if we use a Pythagorean identity for that, that's secant squared theta. So we'll have 3 times the square root of secant squared theta. So we'll just get 3 times secant theta down there. So as I talked about in other videos, you certainly want to make sure you have your trig identities memorized, particularly for trig substitution. Really the only ones that you need to make sure you definitely know is the Pythagorean ones. But the other ones come in handy too. I mean, there are some times once you've done the simplification process and you actually get down to where you can evaluate the integral, there are some cases where you need the other trig identities as well, such as half angle and double angle identities and things like that. So that's what makes trig integration hard for most students, or in trig substitution as well. Just not having the trig identities memorized, and that's ultimately going to be the biggest issue. So certainly want to make sure you memorize those. That way you can avoid it. So after doing the simplification, this is where we're at. So it should be pretty clear that the 3's will divide out the 1, and then we have essentially 2 secants up here and 1 down at the bottom. So that means that 2 of them are going to go, but there's still 1 left over. So now the integral becomes the integral secant theta d theta. So hopefully you're with me on that so far. And remember, the antiderivative of secant theta is ln, absolute value, tangent theta plus secant theta plus c. Recall that addition is commutative, so ln of tangent theta plus secant theta plus c is the same thing as ln absolute value of secant theta plus tangent theta plus c. Some books write it that way, some books write it this way, but addition is commutative. And so, which basically means that no matter what order we have it in, it's the same thing. So this is approximately equivalent to that. So books write things differently, so that's why I wanted to bring that up. Okay, so now we just got to get down to the point where we need to find out what tangent theta and secant theta is in terms of trigonometric ratios. So if you remember SOHCAHTOA, remember that the tangent. Remember that tangent. Remember that's opposite over adjacent. And we also need secant theta, which is the reciprocal of the cosine. So this would be secant theta is equal to, well, since cosine is adjacent over hypotenuse, that means that secant theta is hypotenuse over adjacent if we flip it over. So, and that's what are going to be the ratios for both of those. Now, if we go back to the substitution, x was equal to 3 tangent theta, then tangent theta is x over 3, which means that we have the opposite side and the adjacent side of this right triangle, which means we need the hypotenuse, because secant theta is hypotenuse over adjacent, and that's the side that we're missing. So you just use Pythagorean theorem for that. A squared plus b squared is equal to c squared. So you just sum in the sides you already have. So we'll have x squared, 3 squared is 9. So this would be plus 9 is equal to c squared. And if we take the square root of both sides, we'll get c is equal to the square root of x squared plus 9. And now we have the hypotenuse now. So the hypotenuse now is going to be the square root of x squared plus 9 all over, or secant theta, excuse me, is hypotenuse over adjacent, so that's going to be square root of x squared plus 9 all over 3. And so the triangle is not required that you draw down the triangle or draw the triangle, but it does help to get a bit of a visual. And so when we look at what we have, we now have the opposite, the adjacent, not adjacent, the hypotenuse, which is the square root of x squared plus 9. The adjacent side was 3, and the opposite side was x, right? So if we go back, we took our antiderivative. Remember, it was ln absolute value tangent theta plus secant theta plus c. But now that we have the trigonometric ratios, we have all the sides of the triangle, we just got to plug it in. So this would be ln absolute value of x plus 3 plus the square root of x squared plus 9 all over 3 plus c. But here we have a common denominator of 3, so I'm going to kind of clean it up a little. And we can kill 2 birds with 1 stone and write our final answer. So our final answer for this integral dx over the square root of 9 plus x squared, I'm going to clean it up. It's just going to be ln. Actually, I'll factor out a 1/3. So to be ln absolute value of, well, actually, no, I'll tell you what, I'll write it this way. 1/3 absolute value of x plus the square root of x squared plus 9 plus c. So that would be your final answer. If you prefer to leave it, let's say you want to write it this way, x plus the square root of x squared plus 9 all over 3, then add a plus c. You can leave it that way as well. It doesn't matter. Most professors will be cool with that. So either one of those will work. And that's your solution. So let me know if you have any questions. I'll be more than happy to address it. And so I will see you guys next time, and y'all take care.